Hi, it's Gadget UK here again. In this short video, I'm going to make an adapter from an ATX power connector, so you can plug an ATX power supply into a 1000, Amiga 1000. But of course the emphasis here is on the ATX side of the connector, because that's the fiddly bit. So it might just help you out if you want to make one of these types of adapters for a 2000, a 3000, a 4000 or a 1000 or something else entirely. Right, so I've got an old ATX power connector here that we're going to remove, and we're going to put a, if I can find it, I think it's that one, the opposite gender, so that I can connect an ATX power supply to test it, or one of these, which ultimately I will swap out for a proper one, because this is like a clone and I don't really trust it. Anyway, I've counted the wires I need here from this cable, so I'm just going to cable tie these together, because these are the ones I need. Got two grounds, two 5-volt ones, -5 and +12, I think. No, -12, strangely. That might explain why there's two op amps on this board. I'm thinking they couldn't pull off the amplification required with just the TL084. Anyway, we'll come to that when we look at it. We're not even that far yet. So those are just cable tied together for simplicity. We're going to be obviously removing them at this end, and then I'll have a load of extra cable spare for something else. But the length is good here. You know, if you imagine the connector being here, then we've got loads of room within the case for these wires. And I'm going to keep them fairly long just for the moment. Yes, I'll show you the pin out in a minute that I've worked out here. So you can see I've got some... What are those? Yeah, those are the... What are those? I don't know what those are. Got some contacts. Got an IDC connector there. Oh yeah, that's for the IDE. And we've got male and female. So the male bits go on there, and then the female bits is what we want to wire up to this cable now. Anyway, let's just get these pins out of here, because this is what we're going to need for the female part. Ah, I see, yeah. They're the ones, it's just like a spade, you know, like an angled bit. Yeah, it goes into there like that. So you cut these off individually, crimp and then solder. That's what I'll do, crimp and solder, and then push them in one by one. So it's probably only going to take me 10 minutes or so to do this, so I just need to just trim back the ends of each of these and make it just long enough really to push into one of those crimp connections. The special tools, well, you can get wire strippers to do this, so you'd avoid trimming too much of the, you know, the wire. You don't actually snip into the actual strands, but if I'm careful, should be able to do it this way, I think, with a bit of brute force. So yeah, so trim them back like that, twist the strands together. Really thick wire, this is what you'd expect, because you've got a fair bit of current going across this. I do have reservations as to whether two of these is going to be enough, actually. The original power supply for the 1000 was spec'd at 8 amps on the 5-volt rail, which I guess it probably needed to be for the number of chips it had, and we've got a lot of chips on here. I'll show you one of these, I guess. Let's just trim on one of these off. Yeah, it was thanks to Eric Baquet and Live2, I think, both posted me some links to these connectors. So this is the type of connector you need on a 2000 or a 1000. Obviously the pin count is different. It's a 3.96mm pitch, I think. You can see from the advert here, it says Molex 5239/KK396 style. So, you know, if you look on eBay, you'll find what I found here, kits that has the male and the female connectors, which is ideal if you're building an Amiga 2000 motherboard, or something like I am here, a GBA 1000. Or if you want to replace the connectors on a 2000 or a 1000, either at the male or female end. You know, you might want to replace the ones that go to the power supply, for example, just because they're a bit worn. There we go, that's one. And you can see, you know, there's a little gap there between the two wings. The wire, if you were going to crimp it, you just handle like Amiga kit do. Don't do as they do, I don't think. Yeah, you've got to stick it in there and then crimp it. You know, there's points at the middle of it that crimp together, and then you crimp the neck part. But what I do with these is hold it in there like that on a flat surface, add solder and flux, and then crimp the point here. Anyway, I'll report back. I'm just going to put one of those onto each of these, and then look at the pin out, I'll show you that, and just push them into here in the right order, corresponding to when it goes on here. This edged lip is going to join up with that there. Yeah, so the way I do these and it's not technically the right way of doing it, is hold it like that, try and get it as flat and flush as you can. You've got to be pretty ambidextrous to do this, because you can see I'm using a different finger and thumb on the same hand here to feed the solder. You're better off crimping it first, really. Let's just move that back a little bit, hang on, like that. Yeah, you're better off crimping it first, but with some of these I just come in with the iron, add copious amounts of solder, press the wire in, wet finger, just helps expedite the cooling process. And then what I do is crimp these two things together here, just marginally on the top, because then they start to fold over. Turn it on its side, rotate, and then just one by one try and crimp each side downwards like that. Can you see I've crimped that a little bit? There are special tools to do this. Do the same thing with the other side. Yeah, that's it. You can start to see them come together now. So as I squeeze here, they should, come back together nearer, like that. Then squeeze on that orientation again. You're looking for a sort of square shape there, but a crimping tool will do a far better job here. That's fairly well crimped. I'm not going to mess with that further, but it is soldered in there. There's no way that's coming out. It's rock solid. You could argue it might be more flexible if you didn't solder it. Now there are things, people talk about resistance on solder connections. Yeah, you could get silver alloy. You could argue it's a bit expensive, something like that, but if you wanted a really good connection, you could do that. So the two grounds were after the two 5 volts. Up here was tick. We don't have tick. Tick is a 50 or 60 hertz referenced signal that the Amiga uses for timing. It goes to the CIAs. So all we've got left on the end here now is, I think, -5 and +12. They could be the other way around, so I'll just need to consult the pin out. I'm looking at the schematic here for the A1000. So you've got from the top there -5, -12, -5. Yes, the next one is the 12. And on this ATX cable here, the yellow was 12. So we'll do that one next. Of course, you could argue the less you crimp something like that, the less times, the stronger the connection will be. That's why it's better to use a crimp tool. Anyway, that's done. That's not going anywhere, is it? So I will just consult that diagram again, just to make sure that, yeah, -5 is the last one. So we can stick this in. And there's a little notch there, the flat bit and the notch on opposite sides. The flat bit is what wants to come out of this little hole here. So you put it with a little notch facing up, the spade down. That's it, and then they hook in. So all we're doing now is the -5, which is the white, and then I can get rid of a lot of this wire. We can just put the opposite gender of this on here and just get rid of the extra wires. We don't need them. We're just going to need to leave the green, I think, which is you can use for a switch. So we're going to need to put a switch somewhere for this cable. Right, so I've trimmed those down, so as it sits there, there's going to be enough length to go into the case of the 1000, to go to where power is going to come in, effectively. And I'm going to, you don't necessarily need cables this long. And the shorter the better, actually, with adapters. But I'm not going to be using an actual ATX power supply. We're going to use micro ATX. So you can see I'm cable turning it again. Just try and keep these cables nice and organised instead of just going all over the place. And yeah, just this end now. So lengths are almost the same. where I trimmed it off the other thing. I've got the green here, just figuring I might need one for a switch, and I've got a few more on the floor there for the switch. I might need another one, black one maybe. There we go, so that's right, it goes like that. So, let's take that back out again. Put this back in. Hang on, which way anyway? There again. So what I need to do now is join these up according to the colours here, I think. So I've got my 5 volts at the top here, -5 grounds, and yellow, oh yeah, +12. So they're generally up here, the connections I need. So I need to get the things for this, which I think I've got here. Right, I can't emphasise how hard these are to do. Seriously, I would have never believed that assembling an ATX connector like this would be so difficult. But I've managed to get 3 in so far, and I'll show you what I've learned along the way. I've gone full circle really, so you know, I already talked about in the past soldering the connection in, and I'm like, no, that's not the right approach. And then I tried a few that were not soldered, and I'm like, no, soldering is the right approach. So I'll show you on the microscope with this next one. And 1 or 2 of these pins have died in the name of science. I think 1 actually, I think the other ones I've managed to recover. If I get down on there, let's first of all just trim one of these off. God, I really need some new cutters. These cutters are just like, well, it's like trying to cut with scissors or something. They're awful. Yeah, it's near to the end as you can there. There we go. So we've got our pin. Just try and get a bit of focus on it. Rotate it around like that. Get some flux into there. Someone's bound to say I'm doing this wrong. Don't solder them. It's like I say, if you wanted to get really, really good resistance on the things, hang on, let's just try. Yeah, I just need to work out where I'm going here now. So, yeah, it's starting to fit better each time because I've now got 3 pins gripping it. I can feel those. So I've got a couple of grounds and a yellow. Where's the yellow? The yellow's top corner opposite the red, so let's do that yellow next. Let's disconnect that. So I know where I'm going. It's this, you know, the same side as the first 2 reds, but the yellow. And yes, this is bigger than it needs to be. Not a big deal, it just means it'll accommodate either type of ATX connector moving forward. Anyway, so trim a distance, you know, like, I don't know, 3/4 of a centimetre. That might not be long enough, but we'll just go with it anyway. And it melts back a bit, the covering on that, so yeah, just twist them together. The point I was trying to say there about resistance and solder, you could use, as I said, some silver alloy or something, because you can get silver alloy solder. And then what I do here now is crimp it before I start, so get it lined. Not much better, is it? Anyway, the point is it's just holding it now while we deal with the next bit, which is, and you could argue this wire should be slightly longer. You kind of want it to go right up here, but what you want is this to be flat. Now remember, we've got some flux in there, so I would now flatten this down. If you've got a little flat blade, a jeweler's, use that, because the flatter this is, the better. But this is the easiest way to do these, if you ask me. There probably is a tool you can use that makes this really, really easy. And then we want just a tiny bit of soldering here, and this is the key. You don't want a lot at all. Just making sure I'm still recording. Come down onto that. Right, that is probably enough solder. If you get too much solder in there, wet finger it. Yeah, if you get too much solder in there, what will happen is if it stands up too high in this channel here, this channel is like a plastic notch that slides down here, and that's the thing that holds the cable into the connector. But unless you've got specialist tools, trying to get that in is impossible. But anyway, just a small amount of solder with it, as flat as possible. And then the next issue, you can see the yellow sleeving. What you want to do is get a knife here and go like this, saw sideways like that. It's a case of just, there you go, flattening that, so that when you put it like that, can you see it's flat? So that should now be all good. For good measure, I will do a final crimpy crimp here like this, really tight, and then reevaluate. Do we need to trim any more off? Yeah, we do. Right, that'll do. So I am happy that that is going to be good enough to go in now, and it's going to be resilient enough, I think. What's that on the top? There they go. Resilient enough to stay held. You know, there's enough solder in there just to hold that. But when the plastic notch comes along this channel here and presses onto that, it will be tight getting it in, but it should hold in place. So yeah, as you look down these, there's like a plastic notch at the bottom. Let me show you in the microscope. Can you see here? Plastic notch. So we need to, it wants to be parallel with the first red, this, doesn't it? So what we need is the channel here, yeah, that way. It's going to go that way with a gap here, yeah, into that channel there, and that gap goes across the notch at the bottom. Can you see it? So yeah, anyway, wish me luck. These are a pain to do. I hate them, seriously hate them. I must have spent an hour and a half, 2 hours trying to get these three in, but hopefully this one will go in a bit easier. So I'm using the cam out of the way, using my magnifier here from my parents. Thanks Mum and Dad. Mum's in a really bad way at the moment. I just spoke to her. I hope she starts to feel a bit better soon. They've both had colds on top of my mum having the chemo treatment, and yeah, she's in a bad way, as was Nathan at this point of his chemo, I think. Yeah, so I'm just pushing it in, and if you're really lucky it'll go in really easy. Just occasionally just pull back slightly to see, no, I'm not in yet. You've got to go fairly far forward. Back. Nope, still coming out. Yeah, so what I worked out here is if you've got too much solder, you'll need to remove some of it with a braid. I don't think that's the case. And then what I've done, and there probably is a tool to assist, but I've been gripping the cable. You need thick cable, and push like that towards the connector, straight as you can. And you've got to try this over and over and over until eventually it goes far enough in that the wings at the sides push through the plastic bit, and that's it, it grips. If you're lucky it'll clip, it'll make a clipping noise. And check according to the other pins. That might be in. And then just gently pull it. That's it. When you gently pull it, it made a little noise, just a little bit. That's it, and I can move it forwards, backwards a little bit, and it sort of clicks just a little bit, and that's it. It looks the same height as the other 4 pins, but you see, there was no, what's the word? It didn't sort of go click really firmly. It didn't slot in and click like lots of these things do. I had to force that in with an incredible amount of force. Now it could be because this is cheap, yeah. You've got those little metal wings that stick out on the sides of these pins here, and they get squashed in as it goes in, but they still stick out a little bit, and then you've got to force it. You know, the cable is underneath the bottom bit there, and that plastic white notch is the thing that, as you push it in, it slides down the channel and presses the wire on at that point. That's why they're so difficult to get in, I think. But that bit of solder is the only way you can effectively, I think, with something as cheap as this, push them in without it all sort of coming to pieces when you do it, because I did need to use, as you saw, an incredible amount of force to get those to clip into place, but they're going to be resilient, I think. So I've just got 2 grounds to do and we're done. I am so going to be relieved when this is finished. And here's the final one that I've just done. So you can see, you know, it's flat here, it's crimped there. We could crimp that just a marginal bit more. You know, it's a case of squeezing really tightly there. And then just re-inspect to see, yeah, is there anything that needs shaving off the plastic here? And there is. And it just makes better grip when you do that. You know, because you can, well, you can just grip far better when you've not got a big bulgy out plastic bit. And you can see there's just enough solder to hold it in there, and it's squashed down. There's a bit of solder there. I hope that's not going to cause me a problem. Let's just scratch that. Yeah, it's crazy, but if you do this, then it will be really reliable, I think. And likewise, there's a little bit of solder just there, so I'm just going to just shave there somewhat. You could use like a metal file or something if you were concerned. But you see, these are the things that get caught on the plastic notch when you get it in here, anyway. Yeah, the plastic notch that wants to face up was this one. They're all in a straight line, these, which has been nice. I like it when things are really easy to do. Let's try this. You can see where it is now. I think that one's gone straight in, you know. I think that might be the best one yet. I don't know. Because I'm looking at the bands there, they're all at the same place. I've just pulled. No, you see, it's not in. This is the thing, you need that extra really hard shove to get it to crimp the white HUD, you know, the white piece here, down onto the cable. Because I think ultimately that's the thing that holds the cable in. So normally you wouldn't have to solder it. But I tried doing it like that, and the wire just pulls right out really easy. So soldering it is what I've resorted to. Let's try and push there as straight as I can. Really hard. You want to pull back just 0.5 millimetre, because if you go too far, you won't be able to push, you know. There you go. Did you hear the little noise? And I can now just go forwards and backwards like 0.5 millimetre, and now that's in. Looking at it, it's the right place. That's it. I'm done. Woohoo! I actually thought at various points that was impossible. I thought I was just going to have to buy one and trim it off and join wires up, but I've managed it. And actually we aren't done. We need a green and black for the switch. So the green is from that original cable, and it's a bit thinner. So I've gone with a thin wire for the black as well. It's just going to make it easier, I think. I think it's going to go on to the connector far easier when the wire is thin gauge. But you don't want thin gauge for the main power rails and ground and stuff, but for a switch here, we do. This one's even thinner than that one, but that's all we need. The green went straight in. No worries, and the black wasn't too bad, so yeah, anyway, that's that done. I don't know if these are going to be big enough to go to the switch I want, you know, where it's going to be located in the case, so I don't care. I'll stick some sort of connector on here, JST or something. I might even just twist these two together here. I guess it doesn't really, well, maybe I shouldn't, I don't know. I'll just cable tie them in a couple of places again. So just for the moment, I've got a crazy switch here. This is not what I'm going to be using with this, because this is going to obviously be used with the A1000. Hang on a minute, let's get some fresh solder. I think that might be lead-free solder or something on there. Maybe not, I don't know. Anyway, this is just to test, because it's not really suitable. It's not the right dimension, shape or anything. And again, you know, if I was mounting this properly, I would have some heat shrink tubing or something over the contacts here. wet finger. There we go, that's one. Wet finger. Ow. That's it, so we should be able to go test that now. So we've got our ATX power supply on the bench. Yeah, I'm just facing it this way to make sure. Yeah, that's on, it's got a 1 on there. That switch is so worn, you can't even see the 1 on it. So if we connect to this up here, granted I should have got the smaller connector, but I don't care. Switch it on. Yay! Yeah, let's just measure this side here. It's easier to get the things in those, I think, than the actual things down there. There we go. Minus 4.9. Oh my god, that's not good. Let's check that one. Plus 12. Maybe the minus 5 is a bit low. Yeah, there we go, 5.14. Yeah, the minus 5 is a bit low. This power supply probably needs a recap. The minus 5 is a wee bit low on this ATX, but I suspected this needs recapping for a long while. Anyway, everything's there. The main thing is, if you look at the 5 volts, we haven't got really any voltage drop. 5.14, that's way better than any of those Amiga kit adapters. Right, let's have a go at fixing this thing. Yeah, I need to remember that it goes up there, but I do remember 2 reds on the end. If you're wondering what this is, and I'm still wondering what this is, these pins, you know, if you know what they are, post below. I'd love to know the actual name of them to order from RS or DigiKey or wherever, if anywhere still sells them. But all I did is search for ATX male, female connector kit, and it came with all of the pins for the male, the female, and the hoods, you know, the male and female hoods, you know, you can see them here. There's the pins for that and that piece. It's a good idea getting one of those because they were cheap, a couple of quid or something, and you get all these pins, so it's like I'm not going to use all the pins for everything, which is why I can now fix that, and I've got more pins to fix some of the others. So I'll get another 1 or 2 of those, maybe even 3, thinking ahead, because they're cheap. And, well, it could just get you out of a tight corner when you've got a problem like this with this one. So that has been soldered on before, and that worked for a while, but ultimately the problem with this is the little metal wings there have snapped off, so this just slides in and out. And, you know, you've got unreliability on a 5 volt rail, it's not good. It's not good at all. And you can see this end broke here and has been fixed a number of times as well. Those 2 pieces, look, they couldn't even get the thing the right size, they were glued together. That's crazy. So what I'm going to have to do is uncrimp it. Let's do that with a microscope. Let's get some magnification there so you can see where I soldered it previously. Hang on. And to be fair, that did work. That solved the problem with it, you know, just pulling out. But yeah, we're soldered onto the crimp there, aren't we? That's not good. It's going to make it a bit hard. You can see how weak these things are though as well. And they're like that on these new ones I've got. And so, you know, I'm not really trying to be critical of Amiga kit here. I just think that if you'd soldered them the way I've just done that 1000 one, it wouldn't have come to pieces to start with. But what do I know? I could be wrong. Time will tell. All I know is the ones that have crimped, you know, they haven't come back out again. This one would have lasted, you know, if it wasn't for... I think when I pulled it out, you see, this is the thing, I would have had to get this, pull this out of the connector, and the way you do that is there's a special tool you can get. If you look at this here, hang on, where's it gone now? Zoom you know, focus in. Yeah, there's a tool you can get that goes into these slots, and it's got like 2 pins. It's got like a little pin this side and a pin that side, and you push it in, and it goes into the little gaps near the bottom, and then the pin will come out, is the point. And you can buy those tools. I don't know what they're called. There's a few places sell them for not very much, so I might get one of those. But ultimately, that is why this suffered damage. And look, it's got one of its flaps there. That one's gone, which is why it just falls out. So if we put a new one on, it's got 2 new flaps. And the best way to do this, actually, certainly with the last ones I did, was to get your flux down there, solder the wire first, and then sort of crimp it. I'm going to get so much hate on this video, I know I am. But trust me, that is going to be way more structurally secure and reliable than if you just had the wire pushed in and crimped the way that perhaps it's supposed to be crimped. Anyway, we now need to just get this back into this piece here. As I say though, there's probably a proper tool you can use to do these. That's it. Because as I pull, it's going like that. Push pull. I can move it like 0.5 millimetre or less forwards and backwards. So that's in. Yay! Finally fixed my Amiga kit. ATX side. That side's been fixed. Now that side's been fixed. Yeah, and just because, well, I can, and I always enjoy, I've straightened out. Hang on. Where's it gone? This one. This got mangled. It's one of the ones I pulled out earlier, so the wings there, that needs folding back. And this is the thing, when they get like that, if you're lucky, they'll bend back. If you're unlucky, they'll just break off. Best way to do it is just to bend it a little bit at a time. And then if at some point I haven't got any left, this is what I would fall back to. Because, well, despite how fluffy the end is here, can you see? It's like it got really bent and squashed. I managed to straighten it out somewhat, but it's a bit sharp at the end here. Now, I've just tested this, I'll show you. If I put this into a connector, hang on. Yeah, it makes a nice fit. If anything, it's a bit tight. There we go. Goes in and out, no worries. Because the end's got a bit deformed here, you know, it's all got squashed around. I'm just going to add a bit of solder to the very, very tip. It just means, like I say, last resort, as a last resort, I could use that. There we go. It's just going to stop it folding up and, you know, because all the other parts of this, you know, these here can be spread out, a connection can be soldered in. Those bits there are okay on this one. And the only reason it got damaged is because it went in, the cable came out, and then I had to pull it to pieces. Hang on. You know, I had to pull it out. There we go. Nice snug fit. So at a pinch, I can use that as a spare. And then the other one, which has got one of its wings missing, this is the one we desoldered from the Amiga kit one. It's just that side. It's just that side there. If I could just get a tiny little bit of leverage out there. Yeah, see, at a pinch, I reckon that would work. Ow. Yeah, there we go. Quite a bit further than I wanted to there, but yeah, at a pinch, I reckon that would go in and that would stick. Anyway, I'll just stick those with the other ones. You can see one of the wings has broke off here as well. So you know what, that is a wee bit decrepit, isn't it? But you'd be amazed at what you can fix. You know, if I took this out of a functioning connector and I didn't have another one of these spare, I could, you know, potentially make do with it. Anyway, I do hope you found that video interesting. It's great that we've got this working and I fixed the 2001 as well. So I'll catch you in the next video.